Okay, so velocity. With velocity, you have two different types. You have average velocity, which is kind of like slope. It's like an average rate of change, where it's the change in position, which is your s function over the change in time. And you have instantaneous velocity, which is your standard velocity function, which is actually the derivative of your position function. And then acceleration is the derivative of velocity. If you need the distance of something, that is the absolute value of position. Speed is the absolute value of velocity. And then same thing, these two things come up from time to time for AP calculus stuff. If velocity and acceleration have the same sign, then you can say that speed is increasing, whether they're both positive or both negative. And if they have different signs, then the speed is decreasing. So here is your generalized position function, where s of 0 is your initial height, v sub 0 is your initial velocity, and g is your acceleration due to gravity, which is negative 32. We're going to do two different types of problems. So first one, they want you to find the average rate of change over the given interval, and then find the instantaneous rate of change at the endpoints. So average rate of change is change in position over change in time. So change in position would be f of 3 minus f of 1, just those are your ends, over 3 minus 1. So you would be plugging in 3 to your function, which is going to be 45, minus, when you plug in 1, that's going to be 13. So then you are looking at 32 over 2, which is going to be 16. And since they didn't label those, I wouldn't label that one. So then they want the instantaneous rate of change at the endpoint. So the instantaneous rate of change would be the derivative. Which is going to be 16t. And then they want that at the endpoint. So then they want f prime of 1, which is 16, and f prime of 3, which is going to be 48. And that's all they're asking for. So then these are your instantaneous rates of change. That's your average rate of change if they want you to label it. Alright, so here they have a silver dollar is dropped from the top of a building that is 1,432 feet tall. Okay, determine position and velocity functions. Okay, so position function, got the negative 16t squared plus, you are standing at the top of the building and the silver dollar gets dropped, your initial velocity would be nothing because it's not moving at the beginning. So that'll be 0, and you get rid of that term. And then s of 0 is your initial position if you're at the top of the 1,432 foot tall building, and that's your initial position. So then they want the velocity function. So that's going to be the derivative of position. And the derivative of that top function is just going to be negative 32t. Next thing, they want you to determine the average velocity on the interval from 1 to 3. So that would be your change in position. So s of 3 minus s of 1 over 3 minus 1. So again, you plug 3 and 1 into this function, and then divide it by 2, and you end up with negative 64. And here they talk about t being in seconds. They give you this in feet, so you should label this feet per second. Next one, find the instantaneous velocities at 1 and 3. So that would be using your velocity function. So that's v of 1 and v of 3 So when you plug in 1, you get negative 32 feet per second. When you plug in 3, you get negative 96 feet per second. Next one, it says find the time required for the coin to reach the ground. Fine. So if you're at the top of the building, you want the coin to reach the ground, that means you want its position to be 0. So you want to set your position function equal to 0 and go through and solve for t. When you solve for t, you would subtract divide by 16 square root and then pitch the negative 1. It doesn't make sense that the coin is going back in time. So then t is going to be approximately, because we're going to round, 9.46 and make sure that you go out 3 spaces, 0 seconds. And now they want the velocity of the coin to impact, which means you're going to take this and plug it into your velocity function. However, this is important. You want to take the exact version of this when you plug it in. Don't take the rounded version. You can round your answers, but you shouldn't round the numbers when you use them for future parts of the problem. So we have the rounded version, but you would want to take here when you do the velocity function and plug in the exact version. I'm just going to write this. But again, you want to put in the exact version, which is going to end up being approximately negative 302.734, and then same thing, you want to label and velocity is